Hello all. Today we are going to be covering 11.4, conditional probability. You guys will be able to find conditional probability and use tables to determine conditional probability. So conditional probability is the probability that an event B will occur given that another event A has already occurred. Conditional probability exists when two events are dependent. We talked about dependent or independent events in our last lesson. We also have a special way that we can write conditional probability. You write the conditional probability of B given that event A occurs as this. So you put a little bar between B and A, and you read this, the probability of event B given event A. You can also kind of think of this as your fraction. The probability of event B goes over the event A. A contingency table is a frequency table that contains data from different categories, and these help us find conditional probability. So here we have a contingency table, and we can use this to find conditional probability. Now, there is a chance that you could be given information not in a table and you can still find conditional probability, but the easiest version is on a table. So this example 1 says the table shows students by gender and by type of school in 2005. You pick a student at random and then it asks what is the probability of female given that they go to graduate school. Okay? So you are looking at the graduate school numbers, and you want to know the probability that a person is a female. So you're going to either be looking at a column or row, depending on how the problem is set up. In this case, we're looking at a row. Females given that they're in graduate school. So female number goes on top, that's 1,954, over the total number of students in graduate school. So we have to add these together. I've already done my addition. So we have 1,954 over the total 3,303. Now this, if you write it as a decimal, is about 0.9. And if you write it as a percent, is about 59%. Okay? Now part B is actually more similar to our previous lesson in that we just want the probability of female. Now this doesn't mean P times female, it's just the probability of female. So we want to add up all of our females, and then we take that over our total. So this isn't really conditional probability, it's just a probability. So we are going to add up all the females. And then we put that over our total amount of males and females. And then, once again, I already have these added up. The numerator adds to 9,933, and the denominator adds to 17,472. This, as a decimal, is about 0.57, and as a percent is about 57%. Okay? Now, this next one asks us what is the probability that a student is 4 years given that they are male. So you're going to look specifically in the male category. And then on your numerator, you will be looking at 4-year students. So you'll have for your students, 4,324, over your total amount of males, I've already done my addition. If you divide this, you get your decimal, which is about 0.57. And then you can also find the percent, which is 57%. Now, it's just totally a coincidence that these are both 57%. It's not always going to happen that way. It just happens to be the probability of females out of the total is the same as the probability of four-year students given that they're males. So, just a coincidence. We'll go ahead and go on. We'll just have another example. Americans recycle increasing amounts through municipal waste collection. The table shows the collection data of 2007. So, these ones are worded slightly differently. They don't have our shorthand, our way to tell what information goes on top and what goes on bottom. So we have to think through these a little more. It says, what is the probability that a sample of recycled waste is paper? So this time, you want to look at the recycled waste. I do know it's stated first, so it seems backwards compared to what we were doing. And you want specifically of the recycled waste, what is paper? So you have, if you were to write this out, the probability of paper given that it is recycled. That's how we've been seeing it above. So you have your probability of paper is 45.2 over the total amount of recycled goods. So 45.2 plus 7.2 plus 3.2 plus 2.1 plus 21.7. So the top, the numerator is 45.2, and then your denominator is 79.4. If you write this as a decimal, it actually comes out to 0.569, which really rounds up to 0.57. Now this is extra weird because it's very similar, exactly alike to our past two examples. Once again, just a coincidence. B and C are basically the same problem, except now instead of looking at recycled paper, we'll be looking at recycled plastic or recycled glass. So, if we look at the plastics, you'll have the plastic amount over the total amount of recycled goods, which is the same as above. Then you can just go ahead and divide these to get your decimal and then convert it to your percent. Same thing with glass. You've got 3.2 glass over your total, which is still 79.4. Divide these to get your percent, which is about 0.04. Or sorry, to get your decimal, and then change this to your percent by moving the decimal 2 places. If they had said, what is the probability that you have that paper is recycled, you would be looking at the paper section, specifically at the recycled. So if they had switched this, the probability that paper is recycled would be our row instead of our column. So this would be 45.2 out of the total for paper, which I actually don't have. So we'll find that by adding. out of 83. And then you can find that as a decimal and as a percent as well. Okay, so that's how you can kind of see the order, how it changes, and changes if you're using a column or a row as your total. It's just how it's worded, so you just kind of have to think through it. And lastly, we have example 3. A utility company asks 50 of its customers whether they pay their bills online or by mail. What is the probability that a customer pays the bill online given that the customer is female? Now, I realize that this is written out, and up here, the written out ones, they weren't in the order of like numerator than denominator. This is a little different because it literally states pays the bill online given that the customer is female. So this is the same thing but in words of saying the probability of online given female, while above they didn't have the given that in the statement. So an easier version, it is written out. It's not dealt with the same as A, B, and C here. So we are looking at the female row, and then specifically how many females pay online. So we're going to have 24 over 30. You'll have to reduce this to 4 over 5 if you have to write it as a fraction. And then you can also write this as a decimal, which is 0.8. Or as a percent, which is 80%. So 80% of females pay online, while only 20% pay by mail. And that's all I have for you today. Have a great day.